Hi, Rudy. So today I will present you building a decentralized data platform in Erlang. So first, let me introduce that work. Okay. Sorry. So I'm an Apache CouchDB committer. I'm also a member of the PMC, which is the management groups of the project. I'm a PSF member, Python Foundation. I'm doing a lot of Python with Erlang too. And I'm a web craftsman doing open source for a living. So I'm only selling open source to my customers, and I'm only doing open source during my life and during my work life. So what's Refuge? Refuge is a way to store, share, and render your data, transform your data in a decentralized manner. It's working over on the web, and by that I mean it's using the web as a transport, and it's working on the web with the web technology around. It's open source, or at least it will be open source next week, and it's built in Erlang. So why Refuge? I played a lot with Apache CouchDB. I'm playing with Apache CouchDB since 2007, which is a long time now. And CouchDB is a document-oriented database, period. So you have cool things in Apache CouchDB. You have Couch app that allows you to render your applications, your HTML5 applications. You can store blobs, but you are storing them in the database. It may be efficient for some case, but sometimes you want to store them on other storage. This is what is done by Novacut, which is a video editor, open source video editor under Ubuntu that is using CouchDB as a way to store metadata, but it's storing video on the file system, of course. The real cool thing in CouchDB is the replication, master-master, which means that you can replicate from a source to target and at the same time from the target to source without conflicts. Some hardcore replicator have done 35 replication at the same time. I think I've did much recently with from an iPad to a server with Apache CouchDB. I've done 3,000 replication at the same time to the same nodes, without any conflicts in both ways. Apache CouchDB is working over the web. You can only access it using HTTP, and it's working on the web too, because the replication is only working with the HTTP transport today. It's open source. This is an Apache project, and this is built in Erlang. This is maybe one of the first open sourced database. No SQL database in the world. But what we really want at the end, the thing we all do all the days is first you store your blobs, then you find a way to extract the information from your blobs, and this information that you extract from the blob is indexed right after. Where Apache CouchDB is mixing both. You're storing metadata, which are the schema or JSON objects, the documents, but you attach the blobs to the attachments, to the documents. So you're doing the reverse things. Rather than just storing first your blobs, then indexing it, you do both at the same time. And yeah, so the other way you want is a simple way. What you want first is a simple way, an efficient way to store your blobs and to share them among people or machines. You also want to index and, of course, render them later. The thing I also wanted is to have a way to store, to work with offline device like this one. So I managed to port CouchDB on Android and iOS these days, but this is a pain. CouchDB is not designed for that today, so you have a hack a lot around that. And the other thing that you have to hack is Erlang to make it happen to make it build as an embedded application, not as a script things in your Android or in iOS. But it works quite well, and I want the same for Refuge. So let's start by the beginning, store your blobs. And this is the role of coffer. Why coffer? Because the first thing we all do is putting our data in a coffer. And coffer is a multi-backend storage layer API. So you can store your data on the FS, or on a sharded FS, or on an S-stack solution that I propose to. But you can also store it on LOFS or S3 or whatever you want. Maybe Rackspace, CloudFi, anything. The thing that propose coffer is an API to launch your storage backend, monitor it, and an HTTP API, but not only, to get your blobs, to put your blobs on the storage backends, to delete your blobs, and to list all the blobs you have on your storage backend. This is all what it does. After that, you also want to synchronize it, because you don't want your data on a place. And we are working in a decentralized world. So even if you want to control your data, you may want to store it on S3, but at the same time, you may want to store it on Rackspace, and at the same time, you may want to store it on the machine you have. You can do anything. And coffer allows you to do that in real time with simple synchronous protocols that we will see. It handles partial uploads. One of the things that I hate in CouchDB is when you start a big replications and you have a lot of attachments, big attachments, or maybe not that big, but 10 megabytes is already big when you start to replicate it to a device on a big event with a low bandwidth like it. If you have to restart everything, it will take a long time, and it will use a lot of bandwidth. So I really want a way to, and coffer allows that, to upload your document, and if something happens, the connection hangs, or the end hangs, or whatever, to restart, not from the beginning, but from the last part you uploaded. Coffer was built firstly as an API. So you can embed coffer in your own code, and you can use any transport you want. And coffer proposes you one another transport, which is an HTTP handler, today based on Cowboy, but it will be based on the new HTTP things we will show later in the year. So here is coffer. Yeah. So coffer, you have a storage server which proposes an HTTP API or anything, by default an HTTP API, where you can put, delete, and get your document, which are the HTTP verbs. You can also get all the blobs when listing the blobs. And store it on the blob storage, which can be S3, DFS, or whatever. And each blob storage is organized as a resource. So you can have a resource storing on S3, or you can have a resource that automatically mirroring it to another resource or sharding it to another resource. There are a lot of possibilities. And you can synchronize it with a storage server or with many storage servers. And how the synchronization works. So the thing I forgot to say is that blobs are stored in coffer with a unique ID. Generally, this is the content hash. At least this is what does the default client for coffer. So the only thing you have to send to coffer is a document with an ID, where the name is the ID. And the ID is start by the hash type and the hash. So it can be SHA if you want, or it can be Skyne if you want to store video, because this is a better hashing protocol, or any other protocol you want to use. So because we are using a unique ID for blobs, it's really easy to synchronize between a source and a target. You have already one version of a blobs. You can't update the blobs. So we are better than append only. We have only unique blobs on the disk or on the storage. So the first thing you do when you want to synchronize is to list on the source and the target to detect the blobs that the target doesn't have on the source. Then you synchronize both. You are sending the blobs that you found on the source to the target. Right after that, you create a queue on the source for each pair of source target. So the queue is on the source. And each time a new blob is uploaded on the source, it will be put on each queue. To trigger a replication, the target has to watch on the queue in real time or just enumerate from time to time the queue. Blobs that are already on the target are unsent. So if you have multiple sources coming on the target handling the same kind of files, it will be automatically detected because it works mostly like rsync, where you compare each blob list, ID list on the target. So how it works in Erlang. So at the beginnings, you have a big server supervised that's storing all the configurations for all the storage backends. So if you want to create a resource to S3, you create a resource, you add the configuration to the server, and this server starts the storage backend. Each storage backend is in fact like a gen server. We call it gen storage, and this is a behavior, and it has some known properties, so you can put, you can get, you can delete, you can list, and other things. The backend, the configuration server is starting the storage task, and this storage task is a process that will keep the state between all the clients putting the file, which means that this is only the backend that is only conflict. So if you start to upload the same files twice, the backend will answer with the conflicts. And when you start to put, or when you start to get, the process that is starting to put, or not is starting to get, or starting to delete or list, will be registered in the gen storage. So you can monitor the replication and get the error, and the gen storage is able also to detect if you hang and stop. So what does it mean is when you have an upload that hangs at the end, the client, and the gen server will transform the data he already fetched as a partial upload, and the next time someone is trying to put a new document, it will send it first the number of bytes already uploaded, so you can restart from these bytes, and you don't resend all the documents, all the blobs. Sorry. So this is mostly like this. So you have at the beginning a server where you register a backend storage, and the server, once the backend storage is started, is registered, starts this backend. And yeah. So once the clients connect to the gen server, it could be an HTTP server, it could be an HTTP request, but it could be of any process connecting to the server. The first thing it does is asking for a storage resource. The server is sending back a PID, and with this PID, then the clients connect directly to the backend storage, and then the work is done in the backend storage. So you don't have any single point of failure. If the backend storage hangs, other backend storage will start to will continue to work, and the server will also detect if the backend storage hanged and will restart it. how the synchronization works in Erlang. Since each queue starts a process on the server, on the blob server. Each queue are kept in memory, so they are meant to be low. The blobs are on the disk, so we only put the ID on the queue in memory. We have a process per queue. We are using the process registry to store the queue, so we don't have any other queue system for now. And on update or delete, an event is broadcasted to each queue. And once it's done, it's sent to the watcher. Can be a request or can be another process. This message, and the watcher start to fetch documents. This process per queue makes also sure that the target is always up. So if the target hangs, it will stop anything. We'll keep forward the replication, the queue, sorry. It's launching a timer, and so depending on the configuration you put, it will keep for a while your queue in memory. So if you restart replication, it will take the queue already in memory. It won't restart the call bootstrap. So yeah, enumerate is cheap because we are only storing in memory IDs, so we don't care much. If you want to enumerate rather than having your change in real time, you can just enumerate along the IDs. So how to use your blobs? Because we are only storing blobs. We don't store any metadata. We don't store anything except maybe the dat. But we don't have any story. We don't have any database maintaining your blobs. So you have only blob ID. And the only thing that you can do is listing or getting a blobs by its ID. So you can't do really anything useful with that. But we have some trick in Refuge that allows you to use the blobs. So first, we have ref permalinks. So you can create, just like in Git, you have branch, you have the head, you have the tag. You can create reference in Refuge, and this reference can be updated. And you generally update it and link it to a blob ID. This can be changed. So it can be really interesting. For example, if you start a document, maybe I would take an example like frame paste, which is a paste bin I maintain. So you can create a document rather than trying to delete or update your document each time the paste is updated. You just store a new blobs on the blob server, and what you update at the end is the reference. And then you always have the latest version of your paste. You can, of course, index your data. We show it how to later, and you can share them. If you Refuge offer to you, I will show you later, a way to claim a blob ID. So you can have a redirection. You can create a new blobs with a signature in it, and send these new blobs. Send the ID to friends. The friends coming in, sign it, and you check the claim and send it the right blobs at the end. But I will explain that later. We can take an example. If you want to back up a folder using the blob server, we can imagine this architecture. We have 3 kinds of blobs. We have 2 schema and 1 binary. So we have 1 commit schema to describe the file that is uploaded to your blobs. So you have the blob that is stored on the disk, and this schema will have the ID to these blobs and other information. We have 1 tree schema that is storing the folder. So if you have multiple files, you're storing a list of files saying this is a file type, and if this is another folder, saying this is a folder. And these schema are blobs also. and you keep a ref to track the last tree. It's really similar to Git. In fact, this is Git. I just described how works Git today. And so you can do this with Refuge, except that we are storing here we are storing things as JSON, where Git is storing them as text. But you can also store it like Git. And by the way, you can also use Git as a storage backend in Refuge if you want. So we have the blob ID, the real blob binary. If we want to keep track of the previous version, we are keeping the previous version in that, the old blob ID. A tree is also an object where the key is the file name, having another object, which is the blob ID, and the type, this is the blobs. If you have another folder, this is the folder name. Blob ID to the folder tree, which will be another schema like this, and the type, which is tree. So just exactly like it. What about a blob? Sorry. A post is a blob. A category. So if you want to have a category in blobs, is also a blob. It's working just like tree. And for the home, either you have a blob describing all the blobs that you want to display on the home. So you will have to create it. Some hacker tool like Jekyll can do that. Or you can use an index. I will show you later how. Or you can retrieve, and this is totally optional, all the blob by their dat. You can list all the blob by the dat they have been uploaded on the store. Yeah, the indexer service. So once you have a blob server, you have blob on it, and the second thing you want to do is to index them so you can find them really easily. So a blob server is just, so you have your blob server that have the synchronous protocol, and this is the synchronous protocol that will be used to send the data to the indexer. And an indexer can be anything you want, anything you have registered. It can be an SQL indexer, it can be a document-oriented database like CouchDB or other things. It can be an FTS. So the way it works is just replicate your index to the indexer. An indexer we save a tuple containing the blob ID, the blob, and the dat the blob have been uploaded. And so you get in quite in real time, just for those who know, like change in CouchDB. And then if you want to do some transformation, if you want to only store some parts of your blobs, for example, if you get a blob, this is a JSON, and you want to only store some stuff in your index, a function will be launched to transform that. And it can be any kind of index. So if you also receive a video, yeah, forget that. If you receive a video and you want to extract the metadata from it, you can call a script, extract the metadata, and start to index that in your indexer. Can be any kind of index, so like I said. So behind the scene, it just works like a blob server for the most part. Most important part. So you have a generic server storing the configuration of any indexer, except it only passes the data to the indexer. It doesn't care about maintaining a queue or whatever. You have the possibility to transform the data before, like I said, just like maps in CouchDB. You can pass anything to a function, either in Erlang or by default in Lua using Lua. Sorry, there is no JavaScript, and it won't come from me. I don't want to call any script external to my Erlangs. I don't want to play with that. There is also a simple DSL that allows you to map your document to an index. So if you want to map some kind of field or some kind of pattern you can describe it in a JSON, and I can't show you that right now because this is a target that is already still moving. And the connection between the blob server and the index server are either TCP or WebSocket. So if you want, you can use, I don't know, you can launch maybe a blob server, you can store blobs in your browser and start to open a WebSocket to Refuge and start to synchronize it to the indexer of Refuge and maintaining your blobs in your browser. When your browser comes offline, it just comes offline, stop the indexation, come online, reindex. So you can have multi-browser having your data, and that's all. And so you can use WebSocket or SockJS if you want. If your browser doesn't support WebSockets, or if you want to open more than one WebSockets, everything will be multiplexed. Other thing, yeah, a queue on the index server can be shared between multiple clients. So if you, for example, if your indexer start multiple machine, if you want to dispatch your index on multiple machine and your indexer handles that, your indexer can say, okay, I have some data coming. I'm wanting this machine to connect to the things, to the blob server, and the blob server will share the queue between them and will load balance the data between them. So only one machine will have the information, and you won't have to play with merge or anything to detect duplicates in your index. Yeah, it just works like this. So you have the indexer that span first a queue reader, and this queue reader is responsible of watching the queue on the blob server and fetching the data. It maintains an internal queue, and every 100 blobs, it's sending to the updater this queue, and the updater do its works, passing to the function, extracting metadata if you need it, etc., and then store it on the index. And at the same time, you can have many clients, connecting to the indexer. So everything is parallelized, and if one is crashing, it won't stop the other work. And it also makes sure that the indexation is serialized, so you don't have anything coming in parallel and stuff like it. So we have at the top bottom and in the private part, this thing is not shared by anyone, except your friends if you want, but this is not shared by anyone. The blob server is not shared by anyone by default, and the indexer is not shared by anyone, so you have to present your data to the people. You have to find a way to share your data with others. And for that, you have the Refuge nodes, which is a front end between the blob server, the indexer, and the clients coming on that. It can share any data collection, either created by an index, or by sharing remote queries, or by sharing claims. So a claims is a special blobs allowing you to send an invitation, some kind of invitation to a friend or to a machine to either download all the blobs in a resource or only download the blobs. And this is an HTTP REST API, and behind the scene to connect to the blob server. And to the indexer, it uses Acne. And things I need to commit, maybe tomorrow, which is a new WebSocket client using WSOC, which is a generic WebSockets parser that allows you to create server or clients. And I've designed a client for Acne that use that. So like I said, you have the Refuge node on top, so you have the indexer server here, you have the storage service here, sorry. And everything is private, and here this is under the user control, so this is here that you can also administrate your stuff and add resource, start to upload blobs if you want, create index, create collection, and the collection can be just find all document with type post in this query, in this index, and it will give you a collection that you can share with others. I don't know if some of you read Snow Crash from Neil Stephenson. In Snow Crash, you have hypercard, and hypercard are just a bunch of data that you can exchange between people. And in this hypercard, you have also agents that are applications that can create index or create or render data or find in the data that you already shared. And you can imagine such application with Refuge, and there will be one. So this is mostly a blob like couch app you have, but it contains the way to create new agents, to build new agents or to build new query, depending on the resource you have on your machine or on your private section. So we have this Refuge node, and for now he is alone, and you need to share your data with others. And the way I imagine the way you can share the data is just like Google+. So in Google+, you have circles where you put some people inside, and some people can see anything you have, and some people have the right to speak with the +1 circle. Some other won't, and some other can share with you. For now, this is the only thing that they can do, but we can also imagine some people that will send any data to your circle, and it will be shared. And we can imagine the same things for the data. We can have circle of data or channel of data. A circle of data is just a way, it's just a collection or multiple collection in which you subscribe machine or people to have push or pull rights on that. So how does it work? So we have what I call a hub, and each Refuge node can subscribe to these nodes, can connect to these nodes, to this hub, sorry. This is not needed. You can just give the Refuge node address to your friend or to another machine. You don't need a hub. An hub is just a convenience. You can have private hub. You can have also a hub is also able to proxy your traffic from Tor. So if you have machine coming from Tor, you can also forward them, open a port and forward to public things without saying to others the address, etc. You can do such things. And a Refuge node connect to the hub using a WebSocket. Why WebSocket? Because HTTP works everywhere. HTTP can work over firewall. This is the real technology that passes anything, that works everywhere. And you don't want to play with IP in some country. If you are in Dubai, IP won't work. If you are in another country, your SSH traffic will be firewalled, stuff like it. HTTP always works. HTTPS most of the time too. So once connected to a hub, a node identifies itself with its identity, which is just an ID. And an airbit is launched, sending an up message, and an operative message to the hub to make sure that the connection is maintained. So your hub has no contact with the Refuge node. This is the Refuge node that made the connection. We are in a true decentralized service because a Refuge node can connect to multiple hubs. So you can also load balance your information. Or if a hub hangs, you are still connected to another hub, whatever. Yes. So a hub is mostly working like EPMD in Erlang, except that EPMD maintain a connection to the Erlang nodes to make sure it is still alive. Here we doesn't maintain a connection with the hub. The node maintain a connection to the hub, but when you want to connect to when you want to find the information to get the collection of data or to get the blobs, you connect directly to the node where you have found on the hub. And even if you can do some kind of authentication on the hub doesn't do any authorization. It just presents you, the hub is mostly the circle, and the hub just presents you data for you, and then you can get, you connect to the Refuge node, either pass a signature if you use SSL authentication, or use a barrier token if you use auth, and connect with the barrier token. And the Refuge node will do the authorization for you, which means that you can prevent someone to read the blobs or a collection of blobs, or prevent someone to write, or prevent it to read, but allows him to write whatever you want to do. And behind that, there is also Webfinger Osmeta specification. So you have this Refuge node that register node and data channel to the hub, a Refuge node that search here, another Refuge node that connect directly to the Refuge nodes, and here another hub which does nothing. And when the Refuge node has found the data channel, it just open a direct connection to the Refuge node. I already said that. So about that, the status coffer is released next week, sometimes in the middle of the week. And Refuge will be released, the full application with the full platform will be released sometimes in April. There are some more things I want to speak about. So I work also a lot about embedded platforms, and every service in Refuge can be embedded, which means that you can Refuge node can be also a hub, can be also a blob server, it can be also a query server if you want. And for that, so you can have a standalone node. And wouldn't it be cool if you can, and this is the future prototype of the Refuge box. So this is 4-core ARM platform, ARM CPU, with 2 GB of memory. I had to build Erlang for that because it wasn't available for this platform. This is ARM v8 something. It wasn't. I had to do some little small change in the cross compilation chain, and then right after that, because Refuge doesn't have any C, it was really easy to embed it. So you can launch on top of that, and you can just do what I do with CouchDB. You can also launch it on Android. And the idea behind that is that you can connect to maybe an Arduino and start to collect cells, data from different cells, or feed it with your, I don't know, with the Wi-Fi statistic or whatever. And there are also cool things in the Refuge box that are built in. So the problem when you have such box is that you don't have screen. You can, of course, plug it to a screen, but this is not the goal. So you have to imagine a way to find it, to discover it. And for that, it is using Bonjour, INSSD. So this is built with a package from Andrew, which is a Australian guy that is doing the Bonjour service, which is a C binding to the Bonjour API on Windows and on Mac OS X, and he's using AVI on Linux. And the other way you can discover a device is using UDP discovery. So it's just multicasting a message, and if you open a special code on your Mac or Linux or Windows, you will be able to find the device, the address, and connect to it. via an HTTP hub. The other cool thing is the first time you just put the machine on the Ethernet, but once you found the address, you can plug a Wi-Fi dongle, and it will be automatically recognized. And from it, you can start, and this is fully announced. From it, you can start to configure your networks. So you have some port launch that is creating all the configuration you need and store it. On the disk, it doesn't use the netconfig of the Debian installed. It just uses the ifconfig command and iwconfig commands to create your network configuration. The other thing I've built in is USB watcher. So the moment you start to upload a hard disk, it will detect if it contains some blobs and mount it automatically, or propose to you to mount it in Refuge and start to share data inside. The same for USB key or whatever. The other thing that was starting to work, at least last week, was to plug an Arduino and start to plug some cell and start to feed the data from it, or make filter script to send blobs to the Refuge nodes. Here is one thing I've done. So this is a Refuge node, this time based on the Raspberry Pi. This one, and this is connected to battery, solar battery, which is able to be online during 3 days and connected to a hard disk. And because the Raspberry Pi doesn't have enough power, I have to use USB hub to do that. So it's starting to work well, and it will be available once Refuge will be released in April. The new things too is that we have a new website coming next week, which is completely new looks and all the documentation you want. And the code, you can also track the roadmap on every feature, etc. So it was designed by my cousin, and it's really nice. Yeah, I don't know if I have 5 minutes, but there is also something coming. So I speak a lot about CouchDB, but wrote a new database library, document-oriented database library, which is called Blanket, which is able to handle multi-backends. Can be SQLite, eleveldb, hanoidb, CouchDB. It can replicate with Apache CouchDB, and is designed mostly. It's only designed for embedded device. It's faster than CouchDB when it's uploaded, and it works with coffer. And it is also used as a basic indexer that you have in a Refuge. And that's all. If you have any question.
Do you have pictures of the Refuge box online anywhere? I'm searching.
The Q box, this one?
Yeah.
No, not yet. It will be on the new website anyway. But
Okay.
Probably on Monday when I come back. France. Okay.
Any other questions?
Thank you.